For calculation of pH and pOH, okay, which is pH is a measure of acidity and pOH is a measure of basicity. This P is a small one, not a large one. That's my beautiful handwriting. So let's do some calculations. We'll start with the simple one and then go on to little harder ones. So the first one here is what is the pOH of an aqueous solution of a baking soda of pH 4, and a total pH range is 14. So all you have to do is subtract 4 from 14. I'm sorry, this one should have been 8.4. That's way too simple, okay? Or you could have done that too, okay? However, let's do this again. So 14 minus 8.4, and that gives us 5.6, okay? Because 14 is our range of pH that we can get, and the pOH of this solution is 8.4. So you just subtract that and you get 5.6. So what is the pH of a laundry detergent with a pOH of 3.9? It's the same thing, which means 14 is our range, and then subtract 3.9 from that to give us 10.1. And yes, you can figure out the sig figs yourself. It's going to be 2, so this would be 10, really. Okay, next question then. What is the hydronium ion concentration or hydroxide ion concentration of the following? So this problem I have here because I need you to understand the Kw part, okay? And Kw is equal to the hydronium ion and hydroxide ion concentrations, which is equal to then 1 times 10 to the negative 14, okay? And then that's how we get the pH range of 14. And so this is 14. Each of these is 10 to the negative 7, 10 to the negative 7. So that's how we do this. It's really quite simple. So which means that if you're trying to figure out the hydronium ion concentration and the hydronium is given to you. So to find out the hydroxide for this, it would be 1.0 times 10 to the negative 14 divided by 1.67, 10 to the negative 8, okay? And so then here your concentration will be 5.99 times 10 to the negative 7. So that's the concentration, and everything is going to be in molarity, okay, for this one. So then the next question is hydroxide ion concentration is given to you, 2.29 times 10 to the negative 10. So you would do the same thing, so except now you're calculating for hydronium ion concentration, which it's the same thing as before. So 1.0 times 10 to the negative 14 divided by 2.29 times 10 to the negative 10. And so this gives you 4.37 times 10 to the negative 5. Do the calculation and let me know if there's anything wrong, although there shouldn't be. All right, the next question that we have is calculate the pH or pOH or hydronium ion concentration or the hydroxide ion concentration in the following. So here we have the first one where you have to calculate the pH of 0.0012 molar HCl. So pH is equal to negative log of hydronium ion concentration. For strong acids, the concentration of hydronium ion is the concentration of the solution, so which is minus log of 0.0012, which is equal to 2.92. Okay, that is going to be your answer for this. The next question, hydroxide ion concentration of a solution that has a pH of 3.65. So if you're given the pH, the first thing you should do is calculate the pOH, which is then 14 minus 3.65, which is 9.65. And then you'll have to take the antilog of 9.65. Please learn your calculators well, and you should get an answer of 2.2 times 10 to the negative 10 molarity. Okay, and so make sure that you have the right answer. And then the next one is pOH of a 9.1 times 10 to the negative 2 molar HClO4, which is chlorous acid. No, chloric acid, perchloric acid. Since it's a perchloric acid, it means the only thing you can do for this is actually calculate the pH first. All right, so the hydronium ion concentration here is equal to 9.1 times 10 to the negative 2 molar. So then you calculate the pH of this, which is the negative log of 9.1 times 10 to the negative 2 molar, and that is equal to 1.04. So then the pOH is equal to 14 minus 1.04, which is 12.29. Okay, and so that's your answer. So sometimes things may be a little bit more involved. It may not be a straightforward calculation, but they're very simple though. Don't make it complicated for yourself. pH of a 0.07 molar KOH. KOH is a base. So if this is a base, then the first thing I'll have to do is calculate the pOH, okay, for this one. So the pOH for this is negative log of 0.07, and this is equal to 1.15, okay, and if this is the pOH, then pH is going to be equal to 14 minus 1.15, and that is 12.85. That's your final answer for this. One thing to keep in mind is pH scale and pOH scale, they're going in the opposite directions, okay, so pH, low pH is a strong acid, high pH is a strong base. pOH scale is the other way around, so pOH means a low pOH is strong base, high pOH is strong acid. Okay, they're on opposite.